All right, so today we're going to be graphing inequalities in two variables. Before we do that, we're going to do a quick refresher of graphing an equation. We have y equals 2x minus 3. So we're going to start by identifying our m, 2. Remember though, we want to write it as a fraction, so 2 should actually be 2 over 1. Our b is going to be the number at the end, so minus 3. B is where we begin on our y-axis. So starting at the origin, I'm going to go down 1, 2, 3, and plot my first point. From there, I'm going to use the 2 over 1 as my rise over run. Rise 1, 2, run positive 1. 1, 2, 1. And I'm going to continue that all the way to the edge of my graph. Then I also have to get the other side, so I go down 2 and then left 1. So it's a negative 2 and a negative 1. From there, we're going to use our ID to connect the dots and draw our arrows. So that is how we graph a line by itself. Today we're going to add a little bit extra. So looking at example number 2, if you'll notice, it looks very similar, but we have y is less than or equal to 2x minus 3. So just like we did with example 1, we're still going to identify our m value and our b value. Our m is 2, so we would write it as 2 over 1, and our b is negative 3. So from here, I would go down 1, 2, 3, plot my y-intercept. Then I would use the slope to rise 2, run 1, all the way to the edge, just like on example 1. And then I would go down 2 and left 1 to get the other half of the line. This time though, before I actually go through and draw the line, there are some stipulations. That's what this box right here is for. So it's saying what would the graph look like for less than or equal to. So if you think about 8th grade, you had a number line, so 0, 1, negative 1. And if I told you to shade x is greater than negative 1, you would have an open circle here and you would shade the graph this way. We're going to use this concept to understand our shading. Right here, ours is less than. The way you think about this is based on the y-intercept. So we have a y-intercept right here at negative 3. So if it were less than, we would think about what y values are less than negative 3. While going down on the graph is more negative, so we would want to shade down. So we think about that as shading everything below each one of our points. So we say below, or sorry, shade below. Okay. And then if we think about right here with the open circle, that was not equal to. Remember, with an equal to, ours had a closed filled in circle. Okay, so it had a closed filled in circle. So anytime that we have an equal to, we're going to have a solid line. Same thing goes here. See how we have equal to? That means solid line. But this time, instead of shading below, we have greater than, so we're going to shade above. The less than and greater than are very similar. The only difference is the line. Instead of it being solid, we're going to leave it open like this, so we call that a dashed line. And then less than, remember less than up here, we still shade below. Right here, not equal to, so it is still a dashed line. And then on this one, it is greater than, so just like up here, we're going to shade above. This right here is basically your key, just like on maps. We're going to use this the whole time. So this is super important if you want to highlight it or make sure you know you're looking at that a lot. So now let's go back to our graph. Our graph was less than or equal to. Notice the equal to, we're going to find it right here, a solid line. So when I go to connect my dots, I'm going to use my ID and actually get a solid line again and draw my arrows. Now, the biggest difference is our shading. We had less than. Less than shows me solid line, did that, shade below. So everything below these dots gets shaded. So I'm going to shade this whole bottom part in. And that's how we would shade for inequalities. All right, moving over to example number 3. We have x is greater than negative 5. Notice there's no y here whatsoever. So this line is going to be a little bit different. So we have negative 5 on the x. So we're going to find our x-axis and we're going to find negative 5. 1, 2, 3, 4, 5. What this is telling me is that every single x value I have is -5. So no matter what the y value is, my x value is -5. So I'm going to put some points on there just to kind of help myself see how the line should go. Notice it made a vertical line. From here, I'm going to use my ID to make a vertical line, fill it in. But notice my inequality is greater than but not equal to. When it's not equal to, if you look back at your key, it is a dashed line. So whenever we do this, we're going to dash the line. Notice it's not fully filled in. There are gaps in the line. That's what I mean by a dashed line. Next, it says it is greater than. Notice we don't have an above and below, so we have to think back to 8th grade where we shade right and left. So if this is -5, which values on the x-axis are greater than -5? Well, this -5, -4, -3, -2, -1, 0, those ones are greater. Going this way would make it smaller. So we're going to shade this entire side of our graph. Okay, example number 5. We have y is greater than 3/2 x plus 9. So in this one, we have an m and a b again. So our m, our slope, is going to be 3/2. It's already in fraction form. And our b is 9. So now we graph our b. So we go to 1, 2, 3, 4, 5, 6, 7, 8, 9. Plot our point. And we use 3/2. Normally I would go up 3 and right 2, but I don't have any room, so I must make both of them negative. Down 1, 2, 3, and left 1, 2. And we're going to keep this up until we reach the other side of the graph. So on here, now we have to decide, since it is greater than and not equal to, what should my line look like? It should be a dashed line. And draw my arrows at the ends. Now we decide shading. Our shading says greater than, so we find our y-intercept. The greater values will be above this, so the above part of my line gets graphed. So above each point is what gets shaded, so this entire corner above it. All right, we're going to go to example number 7. On example 7, this one's a little bit different. If you notice, we have 2x minus 5y is less than or equal to -10. It is not y equals. We must have it in y equals, so we need to solve. So just like with equations, we're going to move our 2x first because we want to get this by itself. So minus 2x on both sides. These 0, we bring down -5y is less than or equal to. These cannot be combined, so we rewrite it as -2x minus 10. Last step is to get rid of the -5. We're going to do that by dividing every single term. These are going to 1 out, so we have y. -2 divided by -5, we simplify that, we get a positive 2/5 x. And then -10 divided by -5 gives us a positive 2. Notice the denominator is negative. That means we divided by a negative, so my inequality switches. Now I can find my m and my b. My m is going to be the positive 2/5, and my b will be the positive 2. So to graph it, we go up 2 and plot our y-intercept. Then we rise 2 and then run 5. Oops, there we go. 1, 2, 1, 2, 3, 4, 5, all the way to the edge. Then we go the opposite way. Down 2, 1, 2, 3, 4, 5. Down 2 over 5. So from here, now I just have to decide again, is it a dashed or solid line? So notice my inequality is equal to, that means a solid line. Connect our dots, draw our arrows. Last step is shading. We don't look at the original one, we look at our new one, this one down here. It is greater than because I had to switch it. So we're looking at our y-intercept, the values greater or above. So every value above, we are going to shade. All right, tomorrow in class we will do examples 4, 6, and 8, so make sure you are prepared.